2, 1. Okay, it's surface area today, but first we're going to do a little arc length review. All right, so you're given this function. The first question is not about arc length, but what's f prime? Now, the thing behind this question is, how do you graph this function? If you know the derivative, you know when it's increasing or decreasing. When you can also then get the second derivative, know when it's a concave up, concave down. You can actually graph this by hand by asking questions like this. Now, we said by the second fundamental theorem that the derivative of an integral expression like this is simply compose 2x with this. So we get that. But if it's just x, we plug in just x. But if it's u, a function in x, you got to use the chain rule. What's the derivative of the inner function? It is 2. So there's the derivative. Okay? All right. I'm going to skip b for now because I don't have a lot of time. All right. Yeah, and you can work that out, right? It's going to be 2 rad 4x squared plus 2x, right? Okay. And you can get the second derivative, and you can do sine lines and derivative tests, all kinds of fun stuff. You can actually graph this thing, okay? Here's another thing would be nice to know. For example, the limit as x approaches 1/2 of this thing, of cap f. Well, that's sort of a silly question, isn't it? Is that a plug-in limit? What if you plug in 1/2 where you see x? What's 2 times 1/2? What's the area from 1 to 1 under a continuous curve? 0. So guess what? You just got a 0 of the function, cap f. It'd be nice to know where it has zeros, x-intercepts, y-intercepts, it'd be nice to know where it's increasing, decreasing. It'd be nice to know what the domain is. I skipped that for a minute because I want to get to the arc length. Okay, so the last part of the question is, what's the arc length? They want the arc length from 1 to 2, for x equals 1 to 2, right? And so how do you set up an arc length? We did this yesterday. The length equals the integral from. Well, from what to what?
A to B.
A to B, what are they? 1 to 2. Okay, do you remember the formula? What goes here? Square root of, right?
No.
1 plus the derivative squared. But didn't we get the derivative up here? Square this thing. What do you get? 4 times, then the radical goes away. What's inside, right? So let's write that. 4 times, 4x squared plus 2x dx. Okay, now the game here is, if you get something that you can square root, if it's a perfect square inside, you can probably integrate it. Or if you get something inside that factors out as a perfect square, you might get a u sub out of this. Can you actually do this algebraically? Now, it's rare that you can get 1 plus y prime squared square rooted to be integrable. But this one is. All right, Chris, what'd you say? Distribute the 4? Yeah. All right, so let's do that. So the integral from 1 to 2, square root of 4 times 4x squared is 16x squared plus 8x plus 1, right? I'm writing it in descending order of degree, just to organize it a little bit. And isn't that factorable? In fact, isn't that a perfect square factor? Don't you get perfect square factors? The same factors twice. How do you factor tricky try? Do you remember tricky try? Isn't that tricky try? 16x, 16x over 16. Okay. Now, plus or minus what? How do you decide these numbers? Okay. What? Has to multiply to 16 and add 8. So 4 and 4? Okay. So now if this worked, the 16 should cancel out. Does it? Yeah, because what's the GCF here? 4. You can take out 4 here, take out 4 here, and it cancels all of it, right? So what's left? 4x plus 1 times 4x plus 1. So this is 4x plus 1 squared. When you square root it, what do you get? That's it. So this is easily integrable. Now technically, when you square root a square, you get an absolute value. So I should really put this in absolute value. But it doesn't really matter because on this interval from 1 to 2, on this domain, this is always positive, so the absolute value won't matter. All right, so can you? Sure you can. What do you got? 2x squared plus, right, because it's x squared over 2, plus what? x evaluated from 1 to 2, and now we got the first fundamental theorem. Yay! Got all these theorems running. So plug it in. 2 squared is 4 times 2 is 8 plus another 2 is usually 10 minus plug in 1. 1 squared is 1 times 2 is 2 plus plug in 1. So you get 7. And that's an arc length, so that's 7 units, like feet or something. 7 linear units. All right, so now let's just practice with arc length. And see what's nice about this? I can actually see the goodie. All right. Now, today we surface area. Can you see the time? I see 5:44.